In part 2 of our lesson on oblique triangles and the law of sines, we will do applications of the law of sines. Let's look at this example where we have to solve triangle WIN. So the first thing before you go any farther really is just draw kind of a generic triangle. Think of it as a work surface for yourself. Really, you just need a place to hold the given information and your answers as you work. And you can label whatever vertex with whatever letter you want. Maybe I'll put W here, and I here, and N here. Now we go through the given information and label it on our triangle. So we know that side W is 50 centimeters. So remember, that has to be the side opposite angle W. Side N is going to be 89 centimeters. And angle N is 26 degrees, 20 minutes. Now we have to find all the missing sides and angles. We will round our sides to the tenths place and our angles to the nearest minute. And that makes sense because our angle was given in degrees and minutes, so then we should expect that our answers will have degrees and minutes. Because we know side W here, we're going to be able to find angle W. So we can set up a proportion here that says sine of angle W is to its opposite side, which is 50, has to equal the sine of 26 degrees 20 minutes over its opposite side, which is 89. So then that means, doing the algebra here, we have to take the 50 and cross multiply it up. So now we have the sine of angle W has to be 50 times the sine of 26 degrees 20 minutes divided by 89. So we will get the sine of W is equal to, now we have to grab our calculators. You want to make sure that your calculator is in degree mode. So hit the DRG button and cursor over under degrees and hit enter if you need to. Then you will take 50 times the sine of 26, and then you can hit the degree button, enter, put in 20, then you hit that degree, minutes, seconds button and you cursor over under the minutes and hit enter, close your parentheses, and then divide by 89. Hit enter. And you can see you get a big long decimal, 0.2492909, etc. Now you can store that in memory location A. So hit the store button, cursor under the A and hit enter. Then you know to get at angle W, what we're going to have to do is take the sine inverse of both sides. So we will take the sine inverse of the sine of W, and that's going to have to equal taking the sine inverse of this number 0.249209, etc., that we've stored in A. On the left-hand side, we know the sine inverse of the sine of W will be W. On the right-hand side, we have to take the sine inverse, so we go second, sine inverse, memory variable A, hit enter, close your parentheses, hit enter, and we get 14.43073, etc., all those decimal places. Now remember, our angles have to get rounded to the nearest minute. So we know that W is equal to 14 whole degrees, because that's what's in front of the decimal place. And then way back in Chapter 1, we learned how to take the decimal part. We know we're going to have to multiply this by 60. The easiest way to do that, I think, since that 14.43073 is sitting there in your calculator, is just subtract away the 14, and then now you'll have just the decimal portion in there, and then you can say times 60. And you find out that that's 25.8, and rounding to the nearest minute, we would get 26 minutes. So now we know that W is 14 degrees 26 minutes, and we can label that in our picture. Now, using the triangle sum theorem, we know that we can find angle I, because I will equal 180 minus the sum of the other two. So 14 degrees 26 minutes plus 26 degrees 20 minutes. So first we will need to add up the 14 degrees 26 minutes plus the 26 degrees 20 minutes. And we see that we have 46 minutes So we have 40 degrees, 46 minutes that we need to subtract from 180. So if we start off with 180, we will have to subtract 40 degrees, 46 minutes. We know that 180 degrees will turn into 179 degrees, 60 minutes. And doing this subtraction, we've got 60 minus 46, we know is 14 minutes. And then 9 minus 0 is 9, 17 minus 4, we've got 13. So that means that angle I is going to be 139 degrees, 14 minutes. And we put that in our picture. So the only thing we have left to find now is side I. To find side I, we can use the law of sines, and we want to use the version where we're putting the side on the top, since that's what we're solving for. So we would say that side I is to the sine of its opposite angle, which would be 139 degrees, 14 minutes, will have to equal. Now you have two choices. You can use the 14 degrees, 26 minutes with the 50. However, remember that that was not given to us. That was actually something that we solved for. So the safer bet would be to use the givens. So we will want to use the 89 divided by the sine of 26 degrees, 20 minutes. Whenever possible, always try to use as much given information as you can because it's the most accurate. Now, coming back to our equation, we want to solve for I, so we know that it will equal 89 times the sine of 139 degrees, 14 minutes, divided by the sine of 26 degrees, 20 minutes. Now we grab our calculators and do 89 times the sine of 139 degrees, 14 minutes, divided by the sine of 26 degrees, 20 minutes. And we find out that side I is 131.0 when we round to the tenths place, and the units would be centimeters. So we box in our answer over here in our work, and then we come over to the picture and put the 131.0 there. Now that we have a diagram where all of the angles are known and all of the sides are known, then that means we are finished solving triangle WIN. In this next example, we're told that anchored at point A, so that's here, a boat's pilot sights a shipyard, S, so that's here, at a bearing of north 52 degrees east. So let's see if we can get that drawn in. Remember how bearing works. So the boat and the pilot are here at point A, and they are looking at point S, where the shipyard is. Now, the bearing that they're looking at is north, which means you draw a dotted line to the north. Then you turn 52 degrees towards the east. So you turn this direction 52 degrees. And then you are looking at S. So remember, the pilot is always here. The pilot doesn't walk over here or walk over here or walk along this arc. The pilot isn't moving at this point. The pilot is sitting here at point A, starts by facing to the north, and then staying here simply turns through an angle of 52 degrees towards the east, and now the pilot is looking directly at point S. That's the direction that he's looking. Okay, so we got all of that from the first sentence. Now let's look at the second sentence. It says, then the boat sails east for 1.75 miles. Well, let's just take that much of it and not even the rest of the sentence at this point. So from point A, the boat sails east for 1.75 miles. Now, we know that means it's going to be somewhere going along this direction. This is going to the east. What we don't know is how far is 1.75 miles. Should it be here, or here, or here, or here, or over here? Now, we need the rest of the sentence to give us the clue. It says the pilot finds the new bearing to the shipyard is now north 37 degrees east. So wherever you put your point, maybe we'll call it B. When you get to point B, somewhere along this dotted line, you would then do your bearing of north 37 degrees east, and then you would have to be looking at the shipyard. So let's say for a moment that you made a mistake. So don't write this down. I'm purposely showing you something that is incorrect. Let's say you put point B right here. And you could call it anything. I'm just calling it point B. Now, when you went to do your bearing of north 37 degrees east, you would put a dotted line to the north. You would turn 37 degrees towards the east, and you would say, well, I should be looking at point S, but point S isn't over here. Point S is over here. So that would have told you that you put your point B in the wrong place. In fact, now envision picking this up and sliding it to the left until it makes sense. So that would mean our point B is going to have to be somewhere along here. So that when we do north 37 degrees towards the east, the pilot is looking at point S. So sometimes you'll start off putting a point in a wrong place, and then you'll take out your eraser and say, okay, that was wrong. I'll just erase that and get it in the right place. So now we know that as the boat was traveling east, this is the 1.75 miles. What we are being asked to do is to find the distance the boat is from the shipyard now. Well, here's where the boat is now. So we are being asked to find this distance, and since it's opposite of angle A, I'm going to call it lowercase a. So we have to find A. Now we have a triangle here, and sometimes it's difficult to see inside the triangle when you have these other lines going on. So sometimes what I'll do is I will draw a second picture off on the side where I just label in the information that I'm going to use. This is A, this is B. I know this is 1.75, and this is S. Now we need to find some angles in this triangle. So let's go back to our diagram here. Remember that this was north and this was east. And we know that the relationship between north and east is that they are perpendicular to each other. Remember, this symbol means perpendicular. So we can label that in our drawing. Then that means in our triangle, angle A is going to equal 90 minus 52. So we find out that angle A is going to be 38 degrees, and we can put that in our picture here as well as over here. At point B, we know this dotted line is running north, and from the perspective of point B, looking this direction is looking west. So between north and west, we also know that those two will be perpendicular. Then the angle whose vertex is B, which is this whole angle from here to here, we can see is going to be the 90 degrees of the right angle plus the 37 degrees from the bearing. So angle B is going to equal 90 plus 37 degrees, which is 127 degrees. We label that in our diagram, and then we can put it over here in our picture. Now that really helps us because now we can find angle S using the triangle sum theorem. Because we know S is going to equal 180 minus the sum of the other two. So 38 plus 127. We grab our calculators and enter that in. And we find out that S is equal to 15 degrees. We can put that in our picture here. Now we're ready to find side A. We can use this picture, which might be kind of messy and hard to see through, or this picture, where I think it's a little easier to see. Since we're trying to find side A, we can use law of sines that begins with the side on top. So we have A is to the sine of its opposite angle. Opposite of A is 38 degrees. And that will have to equal the side we know, 1.75, divided by the sine of its opposite angle, which is 15 degrees. Remember to show the algebra. We got to show that we took the sine of 38 and put it up on the right-hand side. So we have A is equal to 1.75 times the sine of 38 degrees divided by the sine of 15 degrees. Now we can grab our calculators and enter the 1.75 times the sine of 38 degrees divided by sine of 15. And in this problem, we were being asked to round to the nearest hundredth, so we discover that A is equal to 4.16 miles. And since this was a word problem, we should state our answer in a sentence. So you could say the boat is now 4.16 miles from the shipyard.